Hello, my name is Lukas Marxer, and I'm here to explain the 2015 AP Calculus exam for question number 4. The first part of the question asks you to consider the differential equation dy over dx equals 2x minus y. After that, for the first part, 4a asks, on the axes provided, sketch a slope field for the given differential equation at the 6 points indicated. The 6 points being 0, -1, 0, 1, 0, 2, 1, -1, 1, 1, and 1, 2. The slopes, or the numerical value for the slopes, I have indicated at the right, corresponding to each of the points, -2, 0, -1, 1, 1, and 3. This question is worth 2 points, 1 point gained for everything being correct in the x equals 0 column, and 1 point gained for everything in the x equals 1 column. The most common mistake, I think, which would cause a student to lose points on this question, would be getting one of the slopes incorrect, or perhaps not indicating properly what numerical value you get for the slope corresponds to what point, leading to a misinterpretation by the grader. And again, this if you get one of these slopes incorrect, or perhaps misinterpret it, then you get an entire point off. So I believe this question is kind of harsh in that matter, so I would recommend the student go slow and make sure that the grader makes it apparent for the grader which slope corresponds with which point. The next part of the question, 4b, is also worth 2 points and asks, find d squared y over dx squared in terms of x and y. Determine the concavity of all solution curves to the given differential equation in quadrant 2. Give a reason for your answer. Fairly simple to solve. Get the second derivative of the given differential equation, which you get to be 2 minus y prime. Plug in for dy over dx, 2 minus 2x plus y. Since in quadrant 2, x is negative or less than 0, and y is positive or greater than 0, therefore, plugging in a negative and a positive value means that a negative value for x and a positive value for y, you get that the equation must be positive. So f of x must be concave up in quadrant 2. The point distribution is as follows: 1 point for defining d squared y over dx squared, 1 point concave up with an explanation. The most common mistake I would see a student making is perhaps not plugging in y prime properly and not distributing the negative. So again, I would recommend the student go slow and make sure that they are aware of what they are doing. Third part of the question, 4c, also worth 2 points, asks, let y equals f of x be the particular solution to the differential equation with the initial conditions f of 2 equaling 3. Does f have a relative minimum, a relative maximum, or neither at x equals 2? Justify your answer. This part of the question is relatively simple. F of 2 equaling 3, in order to find whether or not a relative min or max exists, we must determine that the slope of the tangent line, or the derivative, at that point equals 0. So I ask that, does f prime of 2 equal 0? Plug in the two variables, 2 times 2 minus 3 equals 1, which does not equal 0. Therefore, f has neither a max or a min at x equals 2. Point distribution is as follows: considers the derivative of f of 2 equaling 0, and 1 point for the correct answer of neither with a proper justification. The most common mistake I would say a student would make is perhaps forgetting that a relative min or max is found at the slope of the tangent line equals 0, and perhaps doesn't get any further than that. So I would consider studying up on relative mins and maxes. Last part of the question, 4d, and in my opinion the hardest part of the question, is worth 3 points. And it asks, find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. The student should know that taking the derivative of the equation is necessary to finding whether or not it is a solution to a differential equation. So I take the derivative of y equals mx plus b and find dy over dx equaling m, and and d squared y over dx squared equaling 0. This, as you can see, is my way of solving for m and b, but the answer sheet has a little bit more simple way, which I will show you now. The answer sheet, rather, takes y equals mx plus b, takes the derivative, as I did, and sets it equal to m, or finds that dy over dx equals m. Sets 2x minus y equaling m, using simple substitution, transitive property, and whatnot. But they set 2x minus, or m equal to 2x minus mx plus b. This is by plugging in mx plus b because it equals y. They then go a step further and take m to the other side, setting the equation equal to 0, and grouping the variables. So 2 minus m times x and minus m plus b. In order for the equation to be equal to 0, both 2 minus m and m plus b must equal 0. So setting those two parts of the equation equal to 0, you find that m must be equal to 2, and since you know that m must be equal to 2, then b must be equal to negative 2 in order for that second part of the equation to be equal to 0. Points are distributed as shown. 1 point for acknowledging that the derivative of mx plus b is m, 1 point for setting 2x minus y equal to m, and 1 point for the correct answer, which in this case, m equals 2 and b equals negative 2. There are a lot of things a student can get wrong, perhaps not distributing the negative property properly when finding the derivative of the function, also not plugging in the correct thing and getting stuck. So this is a pretty complex part of the problem, pretty difficult to understand, so I would recommend a student study up on differential equations and complex functions. Thank you for listening.